Okay, good morning to all my students. Hope I am completely audible. Okay, today we are going to start with the new topic, that is year relationship model or entity relationship model. Okay, so before starting the topic entity relationship model, first we understand about the what is the objective of today's lesson and what is the importance of the entity relationship in our subjects or in our subject database management system. Okay, so ER model or entity relationship model means ER model is the backbone of the database design. Okay, so in database design the backbone is the ER model or the entity relationship model. So first we have to identify that thing, that what is entity. Entity means any type of a item, object, product. Meanwhile, any identifiable things can be considered as the entity. It's maybe a person, it's maybe a product, it's maybe a important program, it's maybe any object or anything. Means those particular things are identifiable through some specific features that can be considered as the entity. For example, if I consider about a human, so human can be identified by some specific features. If I consider some biological features, for example, that every human must have two hands, right hand and left hand, and every hand must have some size or must have some physical properties, that number of fingers or something. Okay, if I consider the behavioral of or the designation or social identification of any object human, then it can be categorized. For example, myself as a teacher, someone as an professor, someone as a banker, someone as an industrialist, this can be identifiable. Meanwhile, that an object or an identifiable things can be categorized in different nature. Okay, for example, a person can be categorized depend on their profession, a person can be categorized depend on some biological features, a person can be categorized depend on the social ranking, a person can be categorized depend on some particular any other values. So meaning is that everything, any identifiable objects can be defined as entity, that is not depend on the person. For example, if I consider any item, okay, for example any book, a book must have some features, ISBN, international standard book number. Okay, ISBN number is a features, number of pages, title of the book, publisher of the book, color of the book, binding quality of the book. These can be considered as the features. So now book can be considered as the entity of okay, same as person. So apart from that, if I consider for example bank, okay, so bank have some physical premises, but if I consider a term bank, there is no physical existence. Means a particular house or a particular authority with some operation is considered as a bank. Okay, so a bank must have some properties, for example his address, for example his nature, for example his operation type, means how many operations are performed to that thing. So when you are going to design a large database, first you identify how many objects or how many entities are present in your database. Then you identify what is the relationship between each and every entity. For example, if I take a broad look on an example of our institute or university, for example students are there, first we identify the entity. Students can be considered as an entity. A student must have some features starting with their roll number, enrollment number, their department, their courses. Okay, means some academic features they have, as well as students some have some biological features. That's are true. Yes, a student must have some social features, for example which city he belongs to or she belongs to, okay, from which district she belongs to, from which location she belongs to, from which place she came. Okay, that thing. Same as teacher or faculty member are a separate entity sets or separate entity groups. Same as some physical objects are kept in our university, for example library books, these are considered as a different entity. Okay, same as different physical object. For example, each and every room, each and every classroom, each and every classroom must have considered as an entity. Because of that, each and every classroom must have some basic features. Okay, for example, which section class held here, rooms, how many projectors in room, how many fan or light in a room, means this kind of a things. Okay, so whenever design a university database, we have to identify first the distinguishable entity sets, means each entity set should be distinguishable from others. Then we create the relationship between the each and every entity sets, means how students are connected to the teachers, how teachers are connected to the classrooms, how students are connected to the classrooms. Okay, how teachers are connected to any other objects, for example library books, how students are connected to library books, means different operations, how different operations are connected through each and every entities. So these all things are considered as the entity relationship model or entity relationship or ER modeling. Okay, so what is the objective? Your prime objective should be depend on all these entities and all these relationships. You have to create a whole database, and this database should be a complete structure about your university, means identify all the entities about your universities, design a relationship model, and depend on this relationship model create a whole database that may be on Excel or any kind of a documents, and that is the final one. Means from each particular database you can identify each and every relationship and each and every data about your university. If you successfully complete this goal, then you can say that these are the complete database designing process. So before database designing process or before the actual database planning, first you design the layout. For example, if you are planning for a building construction, first you design the layout. Same as before structuring your data, first you design the layout, and this layout is considered as the entity relationship model or ER model. Got my point? So my WhatsApp number is posted here. If you have any doubt, any confusion or any question or anything, you may directly put the messages to my WhatsApp number. I will surely try to get back to all of these messages and solve your query as well. Okay, thanks. Next we go to the next slide, that our entity relationship model is consist of some basics or broad point. First one is designing phase, second one is modeling. So designing phase is concept about the broad concept of logical design, physical design and conceptual design. Same as the modeling is the architectronics or the whole architecture about the data modeling concepts. Okay, next one is the constraints. Constraints means the set of rules or restrictions or the, for example, the designing issues. Okay, means some restrictions, some relationship restrictions, some rules or set of rules are to be maintained for each data set, that is considered as the constraints. Okay, next one is the ER diagram. ER diagram is a kind of a thing, means it's the physical structure that can be designed in some way. For example, if all the entities are considered through a particular diagram or a particular shape, in ER diagram, when we go to the ER diagram, then we will check that all the entities are identifiable in diagram, means in plan. For example, if you are designing a building plan, in building plan you can clearly put your look that what is the structure. So same as in ER diagram is a kind of a map. In this map you identify all the entities. So how you can identify the entities are closed within a rectangular boxes, means the entities are closed within a rectangular boxes. Okay, means within rectangular boxes how many objects you are finding in a model or a diagram, these are considered as the entities, and each entities are connected with some circular cell or some kind of a circular kind of a cell, that's are considered as the attribute or the features of this entity. Okay, And some entities are connected, means two or three or multiple entities are maybe connected through some diamond shaped object or some diamond shaped connectables. These are considered as the relationship. Meaning is that entities are defined by the rectangular shapes, attributes are defined by the circular kind of shapes, and the relationship are defined by the diamond connected shapes. So later part, when we are going to discuss the ear diagram or ear model, then we will discuss that very broad way. Okay, next is the design issues. Obviously must have some design issues when you are going to design your projects. First you identify the problem objectives. Meaning is that first you identify that what is your basic targets and what is your solution, and to get the solution how many challenges or how many hurdles you have to complete. Meaning is that, for example, when we are going to design a database, to design the database, what is the designing challenges, means what is the limitation, what is the restriction, data restriction, and what is the relationship are there. Okay, these are considered as the design issues. Weak entity sets. Obviously weak entity sets means some of the entity that can be derived from the other entities or that can be replicated in another entity sets. Our target is that we should drop the redundant kind of a thing. Okay, these are considered as weak entity sets. We will focus on that pattern later. Meanwhile, that our base target is that our database system should be very concrete. System should be very concrete. Because of that, no redundant values should be entered and no redundant values should be considered. That save our space and as well as saves the calculation as the relationship methods also. Okay. Now next one is the extended year features. Obviously some extended year features is there. We will discuss that thing later. Next is design of the bank database. It's an example that how can we create a bank database depend on some entities. Okay. Next is reduction in relational schemas, database design, and ending with the UML. Okay, means UML designing. Okay. So first we go to the next slide, then we will discuss each and every parameter. So first we are starting with the designing phase. So designing phase means, for example, if you are considering a small enterprises, so small enterprises have some lesser challenges. For example, if I give an example that in a single class, for example, in only class section A, how many students are there? Nearer 90 or 80 or quite about 100 maximum students. And how many course teachers are there? For example, total 6 or 7 course teachers are there. If I give an example that all of you must do a project and the project should be in a group manner, meanwhile that in each group total 6 members should be there. Okay, and each group is connected with a particular course teacher from your section. So if I divide your section with 6 members, then how many groups are possible? For example, 15, 14 or maximum 18 groups are possible. And if total 6 teachers are there, then each particular course teacher is allocated with 3 groups or 2 groups. Okay. If individually we consider teacher is an entity set, and not students, each project group as a entity set, then each teacher is connected with as max total 3 project group at a time. Okay, so whenever designing this kind of a database, the challenges is very less. Because of this, all the number you are considering that can be solvable through the normal and the pure mathematics. For example, you can divide 100 people, you can divide 80 people, you can divide 90 people, same as total 6 course teachers. Means the manual calculation is possible. But if you consider a large whole database, for example a bank database, for a whole university database, then the situation will be very rose for you. Then you need some kind of a mathematical logic or automated mathematical logic. The mathematical logic derived the solution in some proper way. Okay, so in design phase you must have some challenges. Okay, so in design phase, if we divide that thing, then we have a 2, 3 particular things. First we design the initial phases, okay, then we collect the fundamental or functional requirements, then we present the physical designing. So in initial designing phases, first we understand that how many users are exist, okay. The initial phase of database design is to characterize fully the data need of the prospective database user. Means first we identify the users in your database, okay, then we identify that what is the requirement of this particular users, okay. So in initial phase, first we identify the users and we identify the users data requirement. Means we take a proper look, or we got an assumption that what will be the size of the whole database. So database designer is a planner, database designer is the planner, database designer is the linker part between the actual designing okay. I think feed is properly coming. Someone please reply me. Someone please reply me. Feed is properly coming or not? Someone please reply me. Feed is properly coming. Someone please reply me that video and audio feed is properly coming. Yes, I hope it's properly coming. So 2-3%. Okay, thank you. Okay, it's properly coming. Okay. So at the very initial phase, our main target is that to identify the users and what is the data requirement from the users, okay. So database designer is the planner, database designer is the connectives, database designer is the planners, and database designer is the connectives. Means database designer connect the user requirement and the actual developer target or actual developer work. Means database designer fetch the user requirement, give it to the database designer or the database developer, and they will surely develop the database in a certain proper way. So at initial phase we collect all this kind of a requirement, and next we connect the functional requirements. Functional requirements means after collecting all the user requirements, then we check that things mathematically, that is that satisfiable through some function, is that satisfiable through some functions. So this particular steps is considered as the functional requirements. Means all the user requirements can be fulfilled as a functional requirements, okay. Means all the user requirements can be solvable by the mathematical function, then it is considered as the functional requirements. So after functional requirements, all these requirements goes to the database developers. Lots of database developers are there, then the database developer will design the particular database in some way, then it is considered as the physical phase, okay. So next the designer chooses a data model. I am at a second point. Next the designer chooses the data model, and by applying the concepts of the chosen data model, translates this requirement into a conceptual schema. So totally there, first at initial phase we collect the requirements, and at the conceptual schema phase we develop the table or we develop the model depend on this all these requirements, okay. So a fully developed conceptual schema also indicates that functional requirement of the enterprise. Yes, In what point I am discussing. A fully developed conceptual schema also indicate the functional requirement of the enterprise. Means in a specification of functional requirement, users describe the kinds of operation that will be performed on the data. Meaning is that, for example, you are considering a project. What example I am already put it to you, that project group and teacher are connected through a relationship. What is the relationship? It's the project guiding. Okay, so teacher, on your left hand side, if you consider teacher is an entity, on your right hand side project group is a separate entity. Good. And these two entity means right hand side values and left hand side, these two entities are relation concatenate through a particular function, as this function is considered as project guiding. Means this particular guide project these students. Now what is the functional requirements? Functional requirements is that anytime any project group can enter some project report or put some project report or place some project report, as well as teacher check this project report. After checking the project report, teacher grade some values. Got A, you are got B, you are got C, you are D. Okay. If a student project group receive the grade D, then a student project group need to modify this project once again. And resubmit the project. Yes, resubmit the project. Again the project teacher assess that things. Yes, assess that things. So if you consider the whole operation, you can take a look that a student submission is a kind of a work, teacher assessment is a kind of a work, second, third, teacher grading is a kind of a work, fourth, resubmission from the student is a kind of a work, fifth, modification done by the students is a kind of a work, okay, writing is a kind of a work, then seventh, publishing of result by the teacher is a kind of a work. Means the two entity sets are connected through a relationship project schema, but the project guiding relationship is consist with so many tasks, and these tasks are স্যার আমি একটু ক্লাসে পরে ফোন করছি, লাইভ চলছে, ঠিক আছে? ঠিক আছে। Okay, so many tasks. So if particular relationship project guiding are handling so many tasks, so these tasks are achievable through our database design or not. This is the main point. When a database designer collect all the physical requirements or all the user requirements from both the teacher end and both the student end, student need a certain kind of a database where they submit all that things, and teacher need a certain kind of a database where they can put all this information. For example, if you consider a Google Classroom, in Google Classroom you can submit all your information, same as a teacher can check all that information and provide the grade as well. So here the Google Classroom is a certain type of a database model, okay, and a particular relationship have to complete certain kind of operation, and these operations are considered as the functional requirements. Okay, so got my point, all of you? So in designing phase, what is our learning point? In our designing phase, our main learning point is that we first have initial phase. Next, depend on the initial phase, we design the database with the conceptual schema, and to successful all these things, we need some functional requirements or some functional capabilities. That are the main prime targets in design phases. Okay, so designing phase is mainly divided in a two part. One is logical designing phase and another one is physical designing phase. Those who are attending my classes, please note down, designing phase have two part: logical designing phase and physical designing phase. Okay, so here is the part. The designing phase is divided in two part. Means the designing phase means moving from an abstract data model to the implementation. Means whatever we are planning about a student's project and teacher, these are considered as the abstract data model. Okay, so our target is to make it in a physical platform. So two type of design is there, logical and physical. So logical is deciding the database schema as we discussed, and physical is the actual physical design or layout of this database. So next, logical design have two part, business decision and computer science decision. Business decision means what type of operation you can perform through this particular database. These are considered as the business decision. And computer science decision means the relationship schema. For example, if you have enter some values, then for example to create a table, okay, to create a table you can enter some values through insert. If you want to drop, if you want to provide some rights that a student can drop a project, so you have to, in computer science decision, you need in your database some drop command. Okay, so these are considered as the computer science decision, means whatever as your physical or business decision that can be computerized through some kind of a programming or through kinds of a other tools or through kind of a some relationship or relational schemas. Okay, so these are the broad aspects of the designing phases. Next we go to design approaches. So how we can achieve all these goals? So you are thinking, sir is discussing all these things, so theoretically it's looking very good, and theoretically it's looking very sound that this can be possible through, but the tough is really in our university database our teachers are more than 500. Okay, so in that cases the entities are present in our universities, so that's why first we have to design a basic plan, okay, a basic layout, and this basic layout is considered as the ER model or entity relationship model. So what is here, and after ER model we also discuss one normalization theory. Okay, so normalization theory, I don't know, probably ma'am is taking the normalization theory classes already, or it will be taken very soon. Okay, so in entity relationship model for enterprise as a collection of entities and relationship. Yes, so entity relationship model is a collection of. Next is that entity. What is entity? A thing or object, as we already discussed, a thing or object that can be easily. 1 minute, first check any query from your side. No, nothing. I think it's connected. Okay. Okay. Okay, now I think it's coming little bit. Okay, so if I go to the entity sets, an entity is an object that exists in real world. It is distinguishable from other objects. Okay, so an entity is an object that exists in real world that is distinguishable from other objects. Okay, so I already discussed that thing. I already discussed that things to you, that an entity can be considered as a person, can be considered as an project, can be considered as a company, can be considered as an every identifiable object. And entity set is a considered as an similar kind of object can be grouped in a single set. For example, if I consider about the instructor, then how many instructors are present in your class? Okay, so all these instructor can be grouped in a single set, and this set can be considered as teachers group. So teachers group can be considered as the entity sets. Okay, so an entity set is a set of entities of same type that share the same properties. For example, set of all persons, set of all companies, set of all trees, set of holidays, this kind of a things. Okay, and each entity must have some kind of a features, identifiable features. For example, a man must have some kind of a identification number, her color, complexion, and some different values. So these values are considered as an attributes. Okay, these values are considered as an attribute. I think now feed is coming. Thank you, Ayush. Thank you, Ayush. So now these are considered as the attributes. So each person have some specific features, and these are considered as the attributes. Okay, so if I consider as the instructor have some values. For example, instructor ID, instructor name, instructor street, instructor city, and instructor salary. For example, each course instructor have some course ID, name, street, city, and salary. Same as for each course, the course is not physically present in a real ground. If I say that computer science, is there any physical object identifiable in whole world in name of computer science? No, not possible. So computer science is an abstract kind of a thing. Means computer science, the term computer science is an abstract kind of a object in the whole world. But this abstract kind of a object, the course ID, the course title, and some credits. Okay, so in our university there is not an physical object in name of computer science, but it's an abstract object. So this particular object must have some course ID and some course title, that is computer science, and credits, that particular total 150 credits or 200 credits for the total courses. Okay, so a subset of the attributes form a primary key of the entity set. For example, if I consider as a person, in your departmental teacher, total, for example, number of teachers are there. So what is the unique features of the teacher? For example, with same name, two teacher can be exist. With same height, two teacher can be exist. With same color complexion, two teacher can be exist. With same salary range, two teacher can be exist. So what is the identifiable object? Okay, so the identifiable unique features means primary key is a kind of a things, a single attribute that can be identifiable and distinguished for each and everyone. So that is the teacher's ID. Means each teacher must have an ID, maybe with same name, maybe with same height, maybe with same surname, or maybe with some other attributes or values. So primary key, a subset of the attributes form a primary key of the entity set, uniquely identifying each number of the set. So please note it down this point. These are very important. Uniquely identifying each member of the set. These are considered as the primary key. So in entity sets, got my point? Entity is a kind of a identifiable object that must be there. Okay, so these features are considered as the. Next we go to a relationship. So here the relationship is the example. First one is the instructor, second one is the student. So in instructor database, two column is there. One is instructor ID and second one is the instructor name. Same as well in student database, student ID is there and student name is there. So here you may check that maybe this thing is not present in our example. For example, Craig is the first teacher. Maybe one more teacher the same name Creek should be added in the database. So how you can distinguish this to Creek? So for the distinguishable part, we need different instructor ID at the same place, different instructor ID in the same database. Okay, so here in first table instructor ID is considered as the primary key. Okay, instructor ID is considered as the primary key. Because of that, instructor ID is identifiable and distinguishable kind of a things for each database model. Same as in a student, there may be with same name one more student can be exist in your table. Okay, for example Shankar, 2 times repeated. So how you can identify? So first Shankar is identifiable by 1 2 3 4 5. Maybe next Shankar is identifiable by 1 2 3 4 6. Okay, so with same name, with same student data, the idea is different. Okay. Next we go to the next slide, the types of entity. We already discussed that thing, tangible and intangible. Meaning is that physical and abstract. The concept is again come the physical and abstract. For example, those entity sets are present in real life in your front. Those are present. These are considered as the tangible properties. For example, if I consider that car, pen, bank locker, person, student, these are considered as the physical entity sets or tangible, means that can be mapped directly. Intangible means bank account. Maybe you have a passbook, maybe you have a bank account number, but if I identify a physical property bank account, is that possible? Obviously not possible. Projects guiding. Okay, flight booking. A flight booking is an abstract kind of a thing. So a flight booking must have some specific features, that flight booking number, flight number, time, duration, but does not have any physical existence. Okay, these are considered as the intangible entity sets. So got my point? Tangible entity set can be the physical objects and intangible entity sets can be considered as the abstract kind of object. Those are not present in the physical life. Okay, so next we go to the next slide, that a relationship set. Okay, so a relationship set is a kind of a different thing, means a relationship is an association among several entities. For example, if teacher or students are, how many relationship is possible? Between two entity sets, different kind of relationship is possible. This thing can be keep in your mind very fast, that with two particular entity, more than one relationship can be exist. For example, if I consider that Peter or Peltier is an student entity and Einstein is the instructor entity. For example, if I consider any student name, okay, that is Peter, it's considered as a student entity and Einstein is a faculty entity. So between a teacher and a student, means between Peter and Einstein, there is a relationship. What is the relationship? The relationship considered as advisor. Good. The relationship considered as advisor. Very good. Next, if I consider that each student also mentoring some of the students in university in a randomized way. For example, if you consider myself, I am mentoring some of the students from second year, some of the students from third year, some of the students from final year. That is not bounded to the computer science, that may be expanded to the other stream or other branches also. So for example, I am advisor of Ayush. Okay, very good. Next, for example, when we are randomly allocating the mentor-mentee concept, maybe luckily Ayush is again with the same mentor, means myself. Means as a class teacher, I am advising Ayush, means that time the relationship between me and Ayush is advising or advisor. I am the advisor. So when I am mentoring other students, that time also a new relationship come between me and Ayush, that is considered as the mentoring. Means with same student and with same teacher, different kind of relationship is possible. So in your class, maybe some of the students are guiding by me. For example, I am the project coordinator of some of the students. as well as I am taking your classes in DBMS, as well as I am taking your classes labs in DBMS, I am taking your labs somehow in Java also. Means the relationship between myself and all the student groups are framed through the DBMS theory at a time. It is the one relationship. DBMS lab is the another relationship. Java lab, it's the another relationship. I am guiding some student. For those students, I am the project coordinator. Means for those students, the relationship is project guiding. Means for a same entity sets or a two entity sets, there are different kind of relationships that can be exist. That's my point. Means with two fixed entity set, there are more than one relationship can be exist. So the same thing can be happened in more than two entity sets. Means currently I am discussing or giving this example between me and any specific student from your class, that is one of your friend Ayush or one of your Shubham or one of your friend Aditya, whoever. Okay, means me and a single student, multiple relationship exist. So if I consider that here, means in teacher side, number of teachers are maximum, numbers of teachers are quite large, for example 30 teachers, and students are considered as 2000. So these 30 teachers can be mapped with these 2000 students in some different way. Means these 30 teachers are connected with 2000 students with some more than one relationship. More than one relationships means guiding, mentoring, taking labs, taking theories, okay, taking projects, taking seminars, various kind of things. Okay, so these features are considered as the relationship set. So what is it? A relationship set is a mathematical relation among n greater than equal to two entities each taken from entity set. Meaning is that a relationship set exists when two entities are connected through multiple relationships, or when multiple entities are connected with multiple relationship set. Here we design a set that a small e1 e2 e2 e1 e2 dot en, where small e1 is belongs to entity 1, e2 is belong to entity 2, and small en is belong to entity n. Okay, means each entity is connected with any other entity through some relationships. So these particular sets are considered as the relationship set. Got my point? So where, for example, if I take an example, if I take an example, E1 means the first student Peter is connected with the first teacher Einstein through the relationship advisor. Okay, so here the relationship advisor is connected between the Peter and the instructor. Same as, for example, E2 may be like that the same student, same teacher, but the relationship is project guide. Okay, so this kind of a different features. So a relationship set can be exist when there are more than or equal to two entities and more than one relationships. Okay, then it is considered as the relationship set. Okay, the component of a relationship, for example, it's depend on name, it is depend on degree, depend on cardinality ratio. That is a new term, cardinality. We will discuss that thing later. Cardinality. Okay, so these are the things for today. I think if you go to the next, here you may check the relationship set advisor. That Creek is the instructor. Creek are connected with Tanaka. That is very good. But the teacher Kurd are connected with more than one student, that is Shankar and Zain. Same as if you consider the other teacher are connected with single student, but Kurds are connected with two more students. So these are the relationships. Means this particular instructor are connected with either one student or group of student or sum of student through some relationship, and here the relationship is advisor. Same as this relationship or connectivity can be changed when the project allotment is completed. Maybe that time the Creek is not taking the project of Tanaka, Creek is taking the project of Peter maybe. Okay, so these things can be changed in a later part, one more relationship. So if I go to the next example, here is the next example, that yes, it's a very important thing, that still now we check that entity must have some attributes. Okay, means instructor have some attributes. If you check that thing, instructor have some attributes. The teacher have some attributes, salary, teacher IDs, teacher name, teacher surname, these things. Student have some attribute, department name, student department name, student ID, student name, student surname, student city, like that. So same as if I call the relationship had some attributes also. Yes, relationship had some attributes also. For example, if I am guiding a student, for example, Tomal from your class, any student. Okay. So I have some particular attributes. Tomal have some particular attributes. So what is the relationship between me and Tomal? The relationship is project guiding. I am taking the project of Tomal. So the relationship is project guiding. So this project guiding have some specific features. When the project guiding starting date of project guiding, for example, it's 15th July 2020. Ending date of project guiding, for example, 31st December 2020. Very good. Okay. And apart from that, for example, this kind of features, topic of projects or any other things, means the relationship project guiding also have some specific features like the starting date of project guiding and the ending date of project guiding. So this starting date of project guiding and this ending date of project guiding is considering as the descriptive attributes. So all of you note down this point. These are the very important questions sometime came in your lessons or came in your exam, that what is the descriptive attributes. Descriptive attributes means when relationship hold the attributes like the physical entity or the abstract entity, so that time these attributes are considering as the descriptive attributes. Okay, an attribute can also be associated with a relationship set. For instance, the advisor relationship set between entity set instructor and student may have some attribute like date of initiation of advising. This can be considered as descriptive attributes. So I think for today's lesson these are quite sufficient. Maybe there is something minimal internet lagging or this kind of issue. I will try to remove that things in next session. Okay, not an issue. I think if you have any question about today's lesson, so at this point are not got by me or this point should be repeated or these things, kindly send a message to my WhatsApp. I will surely take care of each and every query, not an issue. Okay, so now I am giving you the attendance link. All of you check this attendance and mark your attendance, and as well as I am posting that thing in your groups also. Mark it before 12:20, only 4 minutes is left. Okay, and I am posting the same thing to your groups. So I have posted the quiz in your class and here also completed.